It's a multiple choice question asking, which of the following does not react with oxygen in the air? So we have four options here. We have iron, magnesium, silver, and we have gold and manganese. So those are the four. We'll take one, iron. Is iron one of those metals that don't react with oxygen? No, it forms iron oxide. And iron oxide with water molecule is rusting. So iron is not the correct answer. Now let's move on to B, which is magnesium. Magnesium also reacts with oxygen to form magnesium oxide. Now remember to your magnesium strict experiment you did in school, and there was a white powder formed, so magnesium is not your answer. Manganese. Now manganese also reacts with oxygen in the air, so clearly manganese is not the answer because it forms manganese oxide. We're left with silver, which is option C. Gold does not react with oxygen in the air. So gold is an inert metal, which means it's very stable, it doesn't react with anything. So gold is the answer. So that's our answer. Now moving to question 7. Question 7 has two parts. Part A is asking for the disadvantage of having formation of metal oxides. Now let's take a look. Rusting of iron is a disadvantage because it can cause weaknesses in structures made of steel. The steel is an alloy of iron, as we learned before earlier on in the topic. So you can remember that steel being an alloy of iron would have rather a big disadvantage because that iron would corrode or rust and make it more weak. So that's a disadvantage. Now as an advantage you would write, when the corroded layer is impervious to oxygen or moisture, it protects the metal underneath. So for example, aluminium oxide, remember the layer is impervious to oxygen. That means it's actually protecting the metal. So this would be categorized as an advantage. And that's how you would define each. Now moving to question 8. It says name 3 metals more reactive than iron that do not corrode as readily due to the formation of a protective oxide coating. Now underline your keyword name, because name means just to write the name, but you have to make sure you write the correct name. So you can't write chemical formulas, you have to actually write the name of the metal out. We have aluminium, chromium and zinc. Now moving to question 9. Question 9 says, why are sodium and potassium stored in paraffin oil? Now we remember that sodium and potassium react readily in oxygen. So they react with oxygen in the air and vigorously with moisture in the air to produce large amounts of heat. And this is why we store potassium and sodium in paraffin oil. So that's your answer for question 9. But then you would also need to justify your answer. To do that, they are stored in paraffin oil to prevent the oxygen or water coming into contact with the metal, because paraffin oil will prevent the contact between water and the metal. Now moving to question 10, which says, write equations for the following reactions. So we have 2 of them. So the first one is a burning of calcium to form calcium oxide. So how would you do that? You would say calcium reacting with oxygen gas to form calcium oxide. After you've done that, you're going to write your states down. So you have solid here, gas and a solid forming. Balance your equation. You have 1 calcium, 1 calcium. You have 2 oxygens, 1 oxygen. So you would have to put a 2 in front of the CaO. And as you make the calcium 2, you have to make the calcium here 2 as well. So you would get 2 calciums reacting with oxygen to form 2 calcium oxide molecules. Now moving to part B, the formation of a surface oxide layer of aluminium oxide. Now again we have aluminium reacting with oxygen to form aluminium oxide. Now this must be easy for you now. We have solid aluminium reacting with gas, the oxygen gas, to form solid aluminium oxide. again you have to balance your equation. So you would go about balancing your aluminiums first. You have one aluminium here, you have two aluminiums here. So first you would write a 2 in there, and then we would have 2 oxygens here, but we have 3 oxygens here. So in order to balance this, what you would do is you would have 3 in front of the oxygen and 2 in front of our aluminium oxide molecule. But then that kind of stuffs up our balancing for the aluminium, because now we have 4 aluminium molecules here. So in order to make it all balanced, we would put a 4 in front of our aluminium here. So that's how you would go about balancing your equation. Now this brings us to the end of the lesson. We covered the reaction of metals with oxides in this reaction. So we looked at corrosion as an example and also looked at the advantages and disadvantages of corrosion.